Hi. Now we will see about ensemble learning. In that we will see about a voting part. So ensemble learning, it is a supervised learning technique, and the purpose of using ensemble learning is to improve the overall performance. So the working is it will combine the prediction from various models, or we can say that we can combine the prediction of multiple models to make a stronger, more reliable prediction. And these multiple models, we will call it as a weak learners or base models. So why we have to use this ensemble learning is in order to reduce errors, and it also to improve the performance, overall performance of the prediction of the model, so that it will do the prediction more accurately. So let us take an example. Suppose if I want to invest in a company, let's say that company is XYZ, and I am not sure about its performance. So what I will be doing, so I will be looking for some advice whether the stock price will increase by some percentage per annum or not. So I will be, I will decide to approach some experts who is having some domain experience. Okay. So these are the persons I will be asking for, like the employee of that company, financial advisor, a stock market trader, employee of a competitor company, a market research team, and a social media expert. So these are the six people whom I might ask about the whether the stock price will increase or not. So if you see the employee in the past, he has been right for almost 70 percentage of time, whereas the financial advisor, he has some 75 percentage of accuracy, and the stock market trader, he has a he has been right for 70 percentage of time, and the employer of that competitor company, he has been right for at least 60 percentage of time, and the market research team, they will be working on that same segment, and they were right almost about 75 percentage, and this social media expert, and he has been right for 65 percentage. Now what I'm supposed to do, given this broad spectrum of access, so I have to probably combine all these information and make an informed decision. So in this scenario, so when all the six expert verify that it is a good decision, so I will be getting a combined accuracy rate. So how I will calculate, in the sense, I will make a percentage. So here if you see, the first person, he has been right for 70 percentage of time. That means 30 percentage of the time he was not correct. So that percentage I will be considering here. So this 30 percentage, so 70 percentage he was correct, whereas the 30 percentage he was not correct. So that 30 percentage I will be considering. So remaining, similarly I will be doing the same for the remaining five experts. Like if you see the employee of a competitor, he has been right for 60 percentage of time, so that means 40 percentage of the time he was not accurate. So that 40 percentage I will be using it. So I will be making the multiplication of all, and I will be subtracting it is from the 1. So I will be getting some percentage which is 99 percentage. So the assumption used here, that all the predictions are completely independent. That's very, very important. So the predictions are completely independent is slightly extreme, as they are expected to be correlated. However, it looks correlated, but all the the outcomes or the answers, all the answers or the predictions from each and every persons are different, and they are independent. Okay. So however, you can see how we can be make sure by combining various various forecasts together. So this is how the ensemble learning works. So an ensemble, it is the art of combining a diverse set of learners together in order to improvise on the stability and the predictive power of the model. So in our example, what we did, the way we combine all the predictions collectively. So okay, so and this is called as ensemble learning. So ensemble based models can be incorporated in two scenarios. One is if you have a data which is of higher volume, and the other case is the data where there is a very little volume. Okay, so in both the cases, you can use this ensemble learning, right? So yeah, on the whole, I have a very small diagram where you can see I have this learning algorithm L1, L2, L3, L4, L5. So I will be using it for a training data, so that I will be getting a strong learning algorithm, right? So in general, there are several algorithms for learning the same task, like L1, L2, L3, and N4, N5. Though these are generally successful, no single algorithm is always the most accurate. So it is like the no free lunch theorem. Okay, I can relate this concept to a theorem called no free lunch theorem, which states that there is no single learning algorithm in any domain always induces the most accurate learners. It will not give you the correct or accurate learning algorithm. So that is called no free lunch theorem. So the usual approach is to try many and choose the one that performs the best on a separate validation set. We may combine, whereas the other case where we can combine multiple learning algorithms or same algorithm, right, with the different hyperparameters or classify. So here I can check which algorithm is performing best, and I can choose the one, or I can combine all the algorithms and I can choose, or I can take one algorithm and I can apply different parameters on that, and I can get a improvised learning algorithm. So here we discuss a model which is composed of multiple learners, so that it can, by combining them, we can attain higher accuracy. In our case, we are taking different algorithms, combining them, and we attain the different we attain the higher accuracy. So this is the basic ensemble structure. So I have the training data, so I can apply it the training data on a lasso regression technique, or I can apply for a KNN algorithm, or I can apply it in a support vector machine, or I can give it to a random forest. So, and I will be taking the combined one, which I am calling it as a meta. So this meta algorithm I will be using for the prediction. So let's focus on one of the ensemble learning algorithm, which we call it as a OT. So OT, it is an ensemble machine learning algorithm which involves making the prediction, which is like taking an average or the summation of multiple machine learning models. If I'm taking an average, then that method we call it as a regression model, or if I'm taking the summation, then we call it as a classification. So here you can see I have a data point the similar to here I have the training data, which I will be applying it to three different models. One is KNN, decision tree, and logistic regression. And at the end of this KNN, I found that prediction is 1. That is true actually. And decision tree, the prediction is false, and logistic regression, the prediction is 1. So I will be making a combination of all the three. The one which is having the maximum value wins. So out of the three values, the prediction 1 is the maximum value. So the prediction is considered as 1 for such data point. So there are two approaches in voting. One is the hard voting and other one is the soft voting. And hard voting involves summing the prediction for each class and predicting the class label with the most votes. So here in our case, I told you the one which is having the highest value, right? The predictions I have given to three different models, and I found the prediction. So each prediction is giving different answers, and the majority prediction wins. So here in our case, prediction is equal to 1. So this is an example for hard voting. Whereas a soft voting, it involves summing the predicted probabilities. Here I have to consider the probabilities for each class label, and I have to predict the class label with the largest probability. Instead of having the value prediction for each value, each class, here I have to consider the probability for each class, and the probability which is with the highest value will be considered as the answer. So that is called soft voting. So with this I will stop. Thank you.